Welcome to the Crazy Hat Chemist. So another video here on kinetics. So let's get moving. Bam! So today we're talking about the Arrhenius Equation calculation number two. So we're going to calculate the rate constant given the following data. So let's take a look at this data here that we're going to look at, and then we're going to calculate what the rate constant. So we got an activation energy, that's 7.25 kilojoules per mole. We have a rate constant at 20 degrees Celsius at 0.277 per second. And we also are looking for the rate constant at minus 10 degrees Celsius. So we're solving for the rate constant at a lower temperature here. So what equation are we using? We are using the Arrhenius equation, but two simultaneous equations, and that is right here up at the top. That is the natural log of k sub 2 divided by k sub 1 is equal to negative e sub a divided by r times 1 over t2 minus 1 over t1. That's the simultaneous equations with the Arrhenius right there for you. So what we're going to do is we're going to plug in these values into those two simultaneous equations, and let's see what we get here from that. So I got a natural log of the rate constant that I'm solving for, and that's that 263.5 Kelvin divided by 0.277 to the negative 1 seconds, that's per second. That's on the left-hand side, is equal to negative, don't forget about that negative sign in front of that fraction there, and I got the E sub A at 7.25 kilojoules per mole divided by the gas constant, that's 8.3145 times 10 negative 3 kilojoules per Kelvin mole. And then the temperature is right here, that's 1 over 263.2 Kelvin minus 1 over 293.2 Kelvin. Now, where are you getting these temperatures from? Here's where you're getting these temperatures from. So you're taking your degrees Celsius temperatures plus 273.15, and then you get your Kelvin temperature. So that's why I get the 263.2, okay? And then the next one here is the 20 degrees Celsius plus the 273.15, and that's where I get the 293.2 Kelvin. Hopefully that makes sense for you. Okay, now we're going to do a little simplification here. We're going to simplify some things on the left-hand side, some things on the right-hand side. We're going to get rid of some of the units that are there so we just have numbers, and we're going to put in the units that are necessary at the end. The rate constant is going to be per second. That's per unit time, so hopefully that makes sense for you. Okay, so we got natural log of k at 263.5 minus natural log of 0.277, and that's equal to negative 0.339. Okay, so that right hand side of the equation is all an entire number. Got rid of the units, they all cancel out. All I'm looking for is that rate constant, which is per unit time. I'm going to figure out what the natural log of 0.277 is. That's 1.284. We're going to move that 1.284 to the right-hand side of the equation with a little subtraction on both sides, and that's what I got. So now I got natural log of k, which is my natural log of my rate constant, is equal to negative 1.623. Now, how do I get rid of the natural log again? Right? Just like addition, subtraction, multiplication, division, those are opposite functions, natural log and e to the. So we're going to use our little e here, and we're going to get rid of that natural log, and we're going to solve for the k. So we're going to take that negative 1.623, we're going to take e to that negative number, and we're going to get this value. The rate constant at the negative 10 degrees Celsius is 0.197 per second. Hopefully that problem worked out well for you. I got another hat here for you here, and thank you very much, McKenna, for this hat. I hope you have the luck of the Irish and can do all these kinetics problems. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. Find me online, and you can find my website with all kinds of great information on there. I'll see you next time. Bye for now.